Hello, good evening to all of you. I hope all of you are doing well. So in today's class, we are going to discuss various matrices used for representing project size. Now, we'll start with the fundamental matrix that is called as source lines of code. Now, source lines of code are software matrices used to measure the size of a software program by counting the number of lines in the text of the program source code. Now, there are two major types of source lines of code. One is called as physical source lines of code. The other one is called as logical source lines of code. Now, physical source lines of code basically implies the lines of code the implementation actually has. Whereas logical source lines of code basically implies the lines of code that are actually realizing the desired objective. So that's the major distinction between physical source lines of code and logical source lines of code. Physical source lines of code are lines of code that are actually present, and logical source lines of code are lines of code that actually realizes the objective. Now, whenever the source lines of code are actually counted, blank lines are also taken into account, but it should not exceed 25% of the total implementation. Now, to further differentiate between a physical source lines of code and a logical source lines of code, let us consider a C program. So in a C program, if we count the total number of new lines, then you'll get physical source lines of code. And if you count the total number of semicolons, you'll get the logical source lines of code, because we know that in case of a C program, a logical statement ends with the help of semicolon. Now let us go through a few of the advantages and disadvantages of SLOC as the matrix for estimating project size. Now, advantages: there is a scope for automating count, because something that can be seen and the physical presence is there. What we can do is we can write a very simple program to automate the count. Now, second important advantage is that it's a very intuitive matrix. It's a very simple matrix to understand. Now let us go through a few of the disadvantages that SLOC has as a matrix for estimating project size. Now, lack of accountability, definitely. Bigger the project problem size, bigger the program size in case of SLOC does not imply that it's a complex program. So it has a very bad correlation with the functional strength. Now, lack of cohesion with functionality. Now, I'll repeat it. Larger the size of the program in terms of SLOC doesn't imply that it's very functionally sound or it's a very complex program. So it may so happen that a program that has greater source lines of code may be a very functionally weak. Now, adverse impact on estimation, definitely. So, what we cannot do is we cannot rely on SLOC as the matrix for representing functional strength, which may have, because it may have an adverse impact on the estimation. Now, SLOC also varies with developer's experience. An experienced developer may be capable of implementing the same within 10 source lines of code, whereas an unexperienced developer may be capable of achieving the same within 100 source lines of code. So it varies with developer's experience. Now, difference in language, definitely. Use of different programming language may result in different source lines of code for representing the same objective. Now, advent of GUI tools. So, use of GUI tools may be heavily penalized because we are capable of achieving the same objective within limited source lines of code. So, SLOC as a matrix heavily penalizes the uses of GUI tools. Now, problems with multiple languages. Lack of counting standards, and SLOC definitely varies with psychology. So these are the set of disadvantages that SLOC has in it as a matrix for estimating project size, which makes it unapplicable in the real world scenario. Now let us move on to the next basis for estimating project size, that is called as function point analysis. Now, function point analysis is a refinement on SLOC as the matrix for estimating project size. What it tries to do is it tries to determine the size of the project by determining the functional strength of a information system. So, greater the functional strength of the information system, greater will be the size of the information system. And one important aspect of function point analysis is that it is independent of the development technologies. Now, the unit of representation or unit of measurement in case of function point analysis is called as function point. Now, functional size can be used in order to budget the application development, to budget the annual maintenance cost, to determine the project productivity, or to determine the software size for cost estimation. Now, function point was initially proposed by Bidge Albrecht. A function point is a rough estimate of a unit of delivered functionality of a software project. Function point measures size in terms of the amount of functionality a system has. So as I've already said, greater the ability of the system in terms of functionality, greater will be the estimation of the size in case of function point analysis. So function point is calculated over a series of steps. The steps are estimation of unadjusted function point, and then estimation of technical complexity factor, and then followed by estimation of adjusted function point. Now, estimation, let us start with the first step, that is estimation of unadjusted function point. Please do not get confused, the steps are very simple. Now, unadjusted function point count or unadjusted function point is estimated taking into consideration five important functional characteristics or function characteristics, that are number of user input, number of user output, number of inquiries, number of files, and number of external interfaces. Again, I'll repeat it. The unadjusted function point count is estimated taking into consideration five functional attributes, which are number of user input, number of user output, number of inquiries, number of files, and number of external interfaces. Now, what does number of user input basically imply? It implies each user input that provides distinct application-oriented data to the software is counted. So each user input that provides distinct application-oriented data to the system is counted. Number of user output, each user output that provides application-oriented information to the user is counted. So number of user input is counted, as well as number of user output is counted. Now, number of user interfaces. Number of user inquiries, sorry. So an inquiry is defined as an online input that results in the system generating some intermediate result in form of online output. So that is called as that's called as inquiry. So each and every user inquiry is counted. The number of logical files. So each and every logical file that is accessed for performing operation is counted. The number of external interfaces. Each and every machine readable interface that is used to transmit information to another system is counted. So what we do is we estimate the unadjusted function point. The unadjusted function point take into consideration five functional characteristics, that is number of user input, number of user output, number of user inquiries, number of logical files, and number of external interfaces. Now, once the unadjusted function point is estimated, is determined. But to move forward, unadjusted function point is determined taking into consideration these five factors. Now, each of these five factors are rated in a 3-point scale. Each of these five factors are rated in a 3-point scale based on their influence, the very existence of the system. Right? Again, I'll repeat it. Each of these five factors are rated on a 3-point scale. Based on their influence to the existence of the system. Like the 3-point scale is simple, average, and complex. So each of these five factors may have a simple influence or average influence or complex influence to the very existence of the system. So these five factors are rated, and the weights are associated weights are determined. So just see here, this is the table that represents the weight as per the 3-point scale, that is average, simple, average, and complex. So now, the unadjusted function point count or unadjusted function point is estimated as summation of factor I into complexity weight. So based on your presumption about what kind of influence that a particular parameter has to the very existence of the system, you will select the appropriate weight. So, for an example, if there are 10 input values, so it has a very simple influence, so it will be 10 into 3. Likewise, if there are 12 output values, so 12 into, it has a complex influence, so it is 12 into 6. So that is the way how the estimation is done. So unadjusted function point is the summation of products of factor of I into complexity weight, where we have created 3-point scale for representing the various weight. Now, once the unadjusted function point count is estimated, once the unadjusted function point count is estimated, now what we need to do is we need to estimate the second important factor, that is called as degree of influence, which will be the basis for estimating the technical complexity factor or the value adjustment factor, right? So we'll come to it in sequence. So we'll try to estimate the degree of influence, which will be a factor for estimating the technical complexity factor. So we'll take into account 14 general system characteristics. The 14 general system characteristics are data communication, degree of distributed data processing, performance, heavily used configurations, transaction rate, online data entry, end users efficiency, online update, complex processing, reusability, installation ease, operational ease, multiple site deployment, and facilitate change. So now these are the 14 general system characteristics that are used for estimating the degree of influence, which will contribute to technical complexity factor later. So each of these 14 factors are assigned values from 0 to 6, depending upon no influence to very strong influence. So again, I'll repeat it. Each of these 14 general system characteristics are assigned value from 0 to 0 to 5, based on no influence to very high influence to the very existence of the system. So now the degree of influence is estimated as degree of influence is equals to summation of the 14 general system characteristics, the value that you've assigned to 14 general system characteristics, right? Okay, then subsequently the technical complexity factor is determined. Technical complexity factor is 0.65 plus 0.01 into degree of influence. So we have taken into account the 1% influence of the 14 general system characteristics for estimating technical complexity factor. So degree of influence is estimated as sum of the 14 general system characteristics, the values that you assign between 0 to 5, and then technical complexity factor is determined as 0.65 plus 0.01 into degree of influence. So once what we have done is, once we have estimated the technical complexity factor, we estimate the adjusted function point or function point. So this is adjusted function point or function point. Okay, this is adjusted function point or function point. So function point is the product of unadjusted function point into technical complexity factor. So function point is the product of unadjusted function point and technical complexity factor. So now what we have done is we have taken into account 5 parameters here for determining unadjusted function point, and we have taken into consideration 14 parameters here for determining technical complexity factor. So altogether till now we have taken into account 19 system characteristics for determining function point or adjusted function point. Now the SLOC is refined as the new SLOC is equals to 16 into old SLOC divided by adjusted function point. Again, I'll repeat it. New SLOC is equals to 16 into old SLOC by adjusted function point. That means here 16 is the adjustment factor, and the factor by which we have refined is the AFP or the adjusted function point. So this is the way how we estimate the project size, the new project size. So altogether, function point matrix takes into account 5 for unadjusted function point, 14 for technical complexity factor, and SLOC for estimating the size. So altogether, it takes into account 20 system characteristics for estimating the size of the software system. So this is all about function point matrix. Now let us move on to the next matrix for estimating project size, that's called as feature point matrix. Now one of the major lag of function point matrix is that, or one of the major limitation of function point matrix is that, in case of function point matrix, it does not take into account algorithmic complexity is one of the prime factor for influencing the size of the software system. So that is done in case of feature point matrix. So in case of feature point matrix, algorithmic complexity is taken into account in addition to function point matrix for estimating project size. So in case of feature point matrix, please listen to me carefully. In case of feature point matrix, the function point matrix is defined by taking into consideration algorithmic complexity. So in case of feature point matrix, for estimating unadjusted function point count in case of feature point matrix for estimating unadjusted function point count, instead of 5 parameters, we'll have 6 parameters, out of which algorithmic complexity is one additional parameter. So we'll have number of user input, number of user output, number of enquiries, number of logical files, number of external interfaces, and algorithmic complexity as an additional parameter in case of feature point matrix in comparison to function point matrix. So rest all of the other steps will remain the same. So feature point matrix is a refinement on function point matrix that tries to take into account one additional parameter while estimating unadjusted function point, that is algorithmic complexity. So these are the three fundamental matrices used for representing project size. So in today's class, what we have learned till now is we have learned the various matrices for representing project size. We have learned what is SLOC. We have learned what is physical source lines of code and logical source lines of code. We have tried to create a difference between them. We try to identify the list of advantages and disadvantages for SLOC as the matrix for estimating project size. Then we moved on to function point analysis, where we try to refine the SLOC by taking into consideration 19 additional project parameters via estimation of unadjusted function point, estimation of degree of influence, estimation of technical complexity factor, and finally estimation of an adjusted function point, which further defined SLOC in order to create a new project size. Then we discuss feature point matrix, which is a refinement on function point matrix that takes into account one additional parameter for estimating unadjusted function point, that is algorithmic complexity, and the rest of the steps in case of feature point matrix remain same. Okay, so these are the various bases that you can use for estimating project size. Okay, that is SLOC, function point, and feature point. Now let us move on to various estimation techniques. Now there are various ways for estimating. There is various techniques for estimating project parameters. The important project parameters that can be estimated are project size. As we have already discussed, we can use SLOC, feature point, and function point for estimating project size, and then effort. Then duration, and subsequently the cost. Okay, so there are various project parameters that can be estimated, and the parameters are project size, project effort, project time, and project cost. Okay, now estimation not only helps in quoting the project cost to the customer, but also used for resource planning and scheduling. Okay, so the one of the primary use of estimation is to quote the project cost, and the secondary use of estimation is to plan and schedule the various resources that are there. Now there are various types of estimation technique. The techniques are named as empirical estimation, heuristic estimation, and analytical estimation techniques. So out of these three, we'll go through the first two, that is empirical estimation technique and heuristic estimation technique. Now, empirical estimation technique are based on making educated guess about the various project parameters. Again, I'll repeat it. Empirical estimation technique is a technique that is based on making educated guess about the various project parameters. Now, if we have experience from the past of developing similar kind of project, then what we can do is we can use empirical estimation technique as the basis for estimating project size. But empirical estimation technique fails in situation where you don't have experience of developing similar project from the past. Now there are two types of empirical estimation techniques. These are called as expert judgment technique and Delphi estimation. Now in case of expert judgment technique, an expert, right? An expert makes an educated guess about the various project parameters and creates the estimate. But in such situation, it may so happen that an expert may not have relative experience regarding all the aspects of the project, which may incur cost or which may incur a certain amount of estimate. So expert judgment technique is heavily relies on the ability and the skill of the expert and the experience of the expert for drawing up the various estimates of the project parameters. In situation where expert does not have a relative idea regarding the various aspects of the software system, then expert judgment technique fails to generate the estimate. In order to overcome that, they proposed the next technique that is called as Delphi cost estimation. So in case of Delphi cost estimation, instead of a single expert drawing the estimates of the various project parameters like effort, size, effort, time and cost, what we have is we have a set of estimators who are assigned with the task of drawing the estimates, and the estimate is drawn. The estimates are drawn over a series of iteration. Now, whenever the estimators are making estimates about the various project parameters, the estimators are not allowed to interact with each other, so that the estimates are not influenced by others' opinion. So in this case, what happens is that each estimator makes the estimate about the project parameters. The coordinator who will be coordinating the entire activity will collect the estimates from the estimators. They will he or she or the coordinator will draw the inferences about the various bases taken into consideration by various estimators for drawing the estimates. Again, the estimates are distributed amongst the estimator for refinement, and the process repeats. The process of refining the estimate repeats until unless all the estimators come up with a near about similar estimate about the project parameters. Now, expert judgment technique and Delphi estimation technique works well only in situation where the estimators have relative experience about developing similar project from the past. And as I've said, it fails in situation where they do not have relative experience of developing the similar project from the past, right? So in order to overcome that, the next estimation technique was used, that is called as heuristic estimation technique. Now, heuristic estimation technique uh, tries to establish heuristics between various project parameters, or relationship between various project parameters. Say, for example, we can have a proportionality relationship, like greater the project size, greater will be the effort, greater the effort, greater will be the time, greater the time, greater will be the cost. So we may have a directly proportional relationship or inversely proportional relationship. So in case of heuristic estimation technique, we basically try to establish heuristics between various project parameter, or relationship between various project parameter, and then we try to convert the relationship in terms of mathematical model using constants. So what we can have is we can have a single heuristics single variable model, or we can have a multivariable model. So in case of single variable model, the estimation uh, representation of estimate becomes somewhat like this. So the parameter that is to be estimated is equals to c1 into e to the power d1. So what we have done is we have converted the heuristics into a relationship by introducing a proportionality constant. Likewise, we can have multivariable model. In case of multiple variable, we have multiple variables that are participating. So the parameters that are to be estimated, the parameter that is to be estimated is equals to c1 into e1 to the power d1 plus c2 into e to the power d2, right? Where there are independent and dependent parameters that are participating. So in dependent parameters are the parameters that are to be estimated. So the parameters that are to be estimated are dependent parameters, and rest are independent parameters, right? So d1 is an independent parameter here. So in case of single variable model, we have only one independent parameter. In case of multivariable model, what we have is we have multiple independent parameters. So that is the basic distinction. So we have just gone through it in brief because this is very simple. So what we have learned is we have learned that there are two types of estimation techniques. There are basically three types of estimation techniques, out of which we have discussed two. One is the empirical estimation technique. The other one is heuristic estimation technique. In empirical estimation technique, educated guess about the various project parameters are made, but empirical estimation technique heavily relies on the past experience of the estimators. If estimator does not have a relative experience about similar kind of project in the past, then empirical estimation technique fails. There are two types of empirical estimation technique. One is called as expert judgment technique, where only one estimator participates in the estimating the basic parameters or the project parameters. In case of Delphi estimation, there are more than one estimators participating in the estimation process, whereas Delphi estimation is done over a series of iterations estimation, where continuous refinement is done to the various estimates that are being made. Now, in case of heuristic estimation technique, what we try to do is we try to establish heuristics, or we try to establish relationship between various project parameters that are to be estimated. So we try to establish relationship between a dependent parameter and an independent parameter, or a set of independent parameters. So likewise, we have a single variable model. In case of single variable model, we have one dependent and one independent, whereas in case of multivariable model, we have one dependent and multiple independent in parameters. So this brings us to the end of this particular class. So in next class, we will discuss few of the heuristic estimation techniques that are used for estimating project parameters. Thank you very much.